Our topic today is integrated photonics, the path from concept to profit. Today's session is sponsored by Chroma Technology, and we're delighted that George from Chroma Technology is here as part of the panel. So let me introduce the panel to you. So in front of me here is Dr. Anton Stroganov from Ligentech. I've said that correctly, yes? He's the head of product management and a member of our Photonics 100. Based in Lausanne in Switzerland, he drives the advancement of high-performance silicon nitride integrated photonics by bridging technical innovation with market needs, guiding releases of new technology platforms and modules. Next, we have Georg Draude, who is general manager at Chroma Technology GmbH, who brings with him extensive experience in sales and management within the photonics and biotechnology sectors. Georg has been with Chroma since 2010, and prior to that worked at Laser 2000. And finally, we have Mike Bader from IMT Microtechnologies. He's area sales manager. Mike has been in the industry for more than 35 years, with experience ranging from manufacturing and industrial engineering through to international consulting and sales management. So welcome to our panel. So we're going to talk about integrated photonics, which is now a hot topic and everyone's talking about it, but we want to kind of drill down into reality of that. So I'm going to start by asking the panel, and we're going to start with you, Anton, because you're actively working in this, to ask about what's happening right now, what's out there actively working, what customers are using it, and what are they using it for?
Yeah, okay, so probably as it's just opening the scene, today pretty much any optical component can be integrated on a chip in a robust and scalable manner. And generally, this means that any optical systems that you can imagine using discrete optics or fiber optics can now be transferred in terms of functionality on a chip. And in this sense, we are somewhat repeating the path of electronics from 70s and 80s, when we are trying to integrate these complex, bulky, and not always easily scalable optical systems on a chip, with quite obvious benefit of size, weight, power reduction, more robust systems because of less interfaces. And of course, it's mainly about scalability. What it means that you can reproduce your system as many times as you want. It can be hundreds, thousands, or millions in a very straightforward and a cost-efficient manner. Of course, there are a variety of materials and different people address it differently. You may know that there are different, we call it material platforms. So basically how you manufacture your chips. It could be the well-established ones, such as silicon, silicon nitride, indium phosphide, but also there are some emergent players, thin-film lithium niobate and others. And of course, all of them come with some strengths and some limitations. So it always depends a bit on the application and the targets that you have in terms of the path that you want to take. In terms of the markets, from what we see, probably we're a foundry, so it puts us in a quite good position to see what's happening in terms of the demand. And we all know that datacom and telecom has always been a driver for the development, both in terms of the technology targets, in terms of the volumes of manufacturing. And previously, 5 to 7 years ago, you can see that it was the case, and only some early stage research in startups or academic environments. But I would say that today it's drastically changing. We see quite a lot of new domains, starting from quantum to LiDAR, navigation, space and defense. They are extremely active. And what I mean by that, that they either explore integrated photonics in the very advanced environment, that they deploy integrated photonics for their next generation products, or that they already ship some products with integrated photonics inside. That's probably in a nutshell how I would describe the current state.
Okay. So George and Mike, you'll have to follow in his wake because obviously he's doing the work at the moment. But what do you see as active markets right now, Mike?
Yes, hello. Thank you very much for having us. Active market for us as a foundry, but for passive photonic elements, is definitely life science diagnostics, where a lot of power and business cases gained up over the last 10, 20 years. And now there is a point where clearly is to see we are talking about photonic integration. Before it was mostly driven by the electron, and now it is a photon affair. And that makes very, very important for the ecosystem, for the global society, like cancer detection. It's a time to death situation. The quicker, the more stable the process and the signals are, and that is approved right now in this industry already, but there's still a way to go. Another one is, of course, you pointed out perfectly, telecommunication. In any case, it's a wide field, a big name, to transfer data from A to B, very precise, very quick, and also already good achievements around, but also still a way to go. Another one maybe is automotive, where we're a little bit involved, because the sensing also is a very important topic when talking about LiDAR, things like that. So these are the three hottest right now, where to say is clearly approved that there is a business case behind, and it will not end up tomorrow because of a lack of money. The industry is already in.
Okay. And George, your business is optics and filters, which is kind of peripheral to the integrated photonics. But how are you seeing the active markets from your perspective?
My main focus is biomedical diagnostic and biomedical research, and I see two different directions. So especially for the diagnostic, miniaturization is driving the use of micro-optics, thinking of going from lab size to bench size to point of care size. The other direction, if you think about more academic and research, optics are also going to grow because we have a bigger field of view on new scientific sensors. We have microscopes with a extended field of view, which is pretty helpful for research on tissue level, which is a big thing. If you think about the keyword proteomics, or what they say these days, multi-omics, where you image tissues down to a level that you can detect single DNA or RNA stranges. And I think that's on a very early stage, but if you think about this multi-omics in 10, 15 years, we are going back in the smaller size.
Okay. So I want now to think about crystal balls and go 5, 10, 15 years ahead and think about where the markets for integrated photonics will be in that time, what's going to grow from what we've got now, what will become saturated. And given that we've got an audience here that are drawn from the vendor side as well as the research side and the OEM side, what are the other opportunities for vendors of peripheral, if you like, technologies within photonics that might also benefit from this path that integrated photonics is taking? So let me start with you, George, with your crystal ball first.
Okay. My crystal ball. I think the challenge is that the market should be ready for going on this smaller scale for micro-optics. Just going back to the medical diagnostics, if companies that are the big players selling body scanners, why would they go downscaling to POCT size if they cannot sell their big MRT machines anymore? And I think this might have been also some regulation from politics and markets, also as a benefit for better healthcare.
Okay, so healthcare is one, right? Yeah. Mike?
Yeah, even we have the slogan precision on and in glass, we haven't got glass balls.
Okay.
To predict, yeah, honestly, I would say be realistic. The more interfaces are in a system, the bigger the challenge will be. The longer the distance is, the bigger the challenge will be. And when taking a look in today's landscape of technologies, promising is what Legion Tech is doing, focusing on the chip level first. That is something where I see the most promising scale-up situation. And when that scales up, the surroundings are coming with it, step by step. And that's what we maybe have to accept, to think in steps. When we want to catch them all, that will burn a lot of money because we have to do it in multiple ways. And we have seen in other industries that's pretty much too much. Even we are talking about quantum and AI, but the basic principles, we cannot feed the system because we don't know how to feed it and what to feed in to make it better. And even AI, we say it is a self-learning, but it learns at first level from that what we are feeding and talking about. So my talk right now will be part of the AI programming for the future. That is what I always try to figure out when talking about the ecosystem. Then do it in small steps, little steps, but do it good. And there is a chip is one of the most promising thing in multiple ways. A lot of companies are involved. And then maybe the next step is going into smaller systems. I'm a completely fan of cancer detection because it's so important. Why not focusing and spending all the power firstly on that? So there is the chance to generate statistical population in a very quick way. And then taking the results into the account and then for the next system and so far so on.
Okay. Anton, how do you see it?
Well, it's always extremely difficult to give predictions in this domain. And that's why I believe I would take slightly different path. I will try not to predict, but rather I will try to pinpoint the trajectories that we had within the last 5 years to see from where we're going and what is the direction. So in this sense, again, we started with telecom because it was what we call a killer application for silicon photonics. It's something which provides you volumes necessary to maintain the process, to maintain the statistically significant knowledge about the process and to ship the products really with the technology. But recently we've seen some new drivers which were probably very difficult to predict 5 to 10 years ago. It's about AI, it's about quantum applications. And for example, quantum computing is extremely important example. Why? Because it brought two important things to the area. First, it's extreme technical requirements. And the second, it's extreme amount of funding that they bring with it, which is a very powerful combination. And generally, what they need is very obvious things. They need extremely low loss, extremely efficient interfaces, advanced integration methods, and to have it very mature and very scalable. So everybody wants it, right? So all the know-how, all the learnings, all the improvements that we are getting now from all this quantum money, we can really directly translate to other domains. And of course, we can expect that it will enable certain other applications which will not progress otherwise. It could be related, for example, to sensing applications. I agree, and sensing in a broad sense, starting from LiDAR to biosensing, highly multiplex biosensing, then OTC systems, and so on. So all the domains which may require higher performance than we have now, but do not have enough budget or momentum to be able to address these improvements on their own. And generally, I believe integrated photonics mainly makes sense in two occasions, either when you have very high volume or when you have very high complexity of the system. So these are the primary domains which will benefit from all the current developments.
Okay. So we're here at Laser World of Photonics, and by virtue of that fact, we all understand what the term photonics means, and to some extent, some of us understand what integrated photonics means as an extension of that. But obviously, the applications for integrated photonics are largely in applications that don't know what photonics is. It's a means to an end as opposed to the end in itself, if that makes sense. So how, as we kind of move into the challenges from where we are now to where we're going to be in that 10, 15 years' time, what work have we got to do on education of the markets and the potential markets? Are there political barriers to that sort of thing? Are there technological barriers that stand between us and those markets in 10 to 15 years' time? Mike, let's start with you on this one.
Yeah, thank you very much for asking. That's really a good question, which tackles, which hurdles we've got to tackle. Where are the limitations? And from educational point of view, I learned, for example, in China, that they made a plan how to integrate technology into the schools. So they have asked some major players in the industry, what is your proposal? And they asked the people with children. That was the most important step. And so they asked the right people. And then they built up small machines like 3D printers as one of these outcomes. A 3D printer with that size and with a nice field with a cat, with a dog, maybe a pig or whatever, a flower. 6 buttons. That was it. The starting point for a 6-year-old child. And what did the child do? It pushed the button, and the printer made a flower. This child was attracted. So we have to bring a very easy way to the society to understand. I remember the time when there was the big discussion of the Higg and the quark and all these things, which as an outcome from the CERN in Switzerland, from the collider. Finally, that was a high-stake discussion made in media. Everybody asked everybody, do you know what they are talking about? And that is maybe something as a outcome for myself. Keep the thing simple. Give it easy names that a child can understand, and then you got everybody. That is maybe one of the major soils when talking to future steps. Another one is, for sure, politics. We have to learn and to accept that the people are living in different cultures. And that's a matter of respect. I want to have a respect from everybody, so I have to give respect to everybody. And I don't have the position to blame the German chancellor or the guy in the US or the guy in Russia or the guy in Iran or wherever in the world. It's not up to me. I just can give respect to everybody. And when I start with that right now, and everybody starts, then we have maybe an easier position to bring technology to the world and across the borders. I by myself go to conferences all over the world, talk to people from universities, from scientific institutes, as well as industry players, and always the same. Let's talk in an easy way and respect each other. That's the easiest at what everybody can do. And the third thing is maybe there was a nice song in the 90s, Don't Believe the Hype. When we feed each hype, nobody can follow that. So same situation. Make a clear mindset or a clear understanding where to spend money first. We can't spend money for each and everything. Otherwise, we have to print it day and night. Some countries tried it already, but they failed. So let's focus on what is easy, the next step to do like that. And that is my personal understanding of global improvement, okay. What I can do, what everybody can do.
Anton, well, maybe talk a bit more about the kind of technical hurdles we have to cross between now and 10, 15 years' time.
Yeah, sure. But first of all, I fully agree with Mike that awareness about the technology on the end user side, on the engineer side, on the technician side, on the producer side, it's extremely important, because if nobody knows about the technology, it's very difficult to expect that it will be improving and taking more space in our daily lives, right? If we speak about technical challenges, probably I can simplify it and summarize it to interfaces. So ideally, what we would like to see is that there are some applications in which we ship a lot of products and they reach consumers after all, right? But for that, what you need is a very well-established supply chains and ideally standards, because what we see nowadays with integrated photonics, with a lot of different materials, with a lot of different approaches, it's a bit of a wild west. And what we need to have is basically that we have agreement on the standard approaches, agreement on the standard interfaces, and that supply chain allow us to really combine different best parts into one solution. Because for the moment, sometimes you know which parts you need. You have very well-established supply chain to produce separate parts, but as soon as you need to assemble them into the final functionality, it just doesn't exist, because they either never work together, or the standards are different, or materials are not compatible. And I believe it's a huge challenge which we need to overcome. And this may be overcome only with support from the community or from an application which really drives it forward, which cannot appear or be enabled without this type of interfaces. I would kind of, on a high level, summarize it this way.
Okay. George.
I mean, I just would catch on what Anton is saying, that interfacing is very important. And if you want to go into successful integrated photonics, then you have to understand that the different components have to work perfectly together. This is what we face every day these days, when I'm mainly doing optical filters, and people reach me out in 95 of cases at the last question. So they have everything set up with their optical bench for the prototyping. They have the camera, they have the detector, everything, and then just saying, hey, we need a filter, and oh, you also offer custom solution. That's interesting. So I think thinking of the whole concept and in the very beginning and making sure that the components working good together is very crucial. And this is the start of the process to get an integrated photonics.
Okay.
I just want to say one more word. What Mike was saying about politics, I think that's very important. What he said, that regardless of passport, regardless of religion, regardless of ethnics, we should work together and don't get blinded by war situation. Is it a real war or is it a trade war? We have to work together and make sure that we build the future for a better world.
Okay. We've got about 5 or 10 minutes to go, so I'm going to ask if there are any questions from the audience in a couple of minutes. So prepare those questions. I'm looking at you, Finn. So I maybe just want to pick up on that last point there about partnerships and collaborations and maybe government funding and things like that. What's going to be the stimulus? What needs to happen to get people to work together to support the growth of integrated photonics as a sector, as an industry in and of itself? George, let me start with you on that one.
I think the most important thing is that academics works very close with industry, and also the other way around, that industry is making a clear wish list what they want to have the graduates educated in, and also on the other way around, giving the support to the academics that they understand what is needed and collaborate very close together.
Okay. Anton?
Well, it's a difficult question, so I think I would rather comment on what may prevent us from doing the right things, because I believe sometimes we make decisions without really understanding how the industry works, because I believe it's the case for many technologies, not only for integrated photonics, but it's a challenge and also it's somewhat an intrinsic property of the industry. So integrated photonic circuits and any kind of integrated circuits, it's always high fixed cost technology, if I may call it this way. And there are two levels. First, it's about infrastructure. So to be able to build a dedicated fab or a dedicated technology house, it's always extremely high investment needed. Here we can speak easily about hundreds of millions if you build it from scratch to something which is somewhat competitive in the current situation. And also the installation of new processes, for example, even in the existing infrastructure, it's quite a costly and lengthy process if you do it appropriately. And generally it's okay, but it may become an issue with all the geopolitical tensions and all the fragmentations that we see today, even within Europe. And I believe now, with all the situation, we sometimes see that a lot of money, a lot of resources, a lot of funding is going into replication of the things and repetition of the things which were already done elsewhere, even within Europe. And this definitely slows us down and does not allow to move at the pace at which we would like to move.
Okay. Mike?
Perfect explanation. When riding across the world, seeing white papers all over the world, you can count around 10 times the same topic, 10 times the same build-up, and all made by fundings from governments. So maybe it's sometimes the access to get money for the initial funding is maybe too easy sometimes.
Okay.
And then to have the chance for level 2, this is too complicated. So that is, in my opinion, is a disbalance in all this administrational effort to put for startups, for example, but also for industry players like us. We would love to do more with universities. We are doing a lot, but we would love to do more. But there's so much administration around. When it goes to the next level, it's easy to get the first one, but the second one is a massive amount of administration. Sometimes the money is maybe too cheap, that it's too easy to start 10 times the same thing.
Okay.
That's another topic, but hard to describe how to solve that issue. And another one is for sure that the barriers, the market barriers, in some markets are not necessarily so. Keep it down. Make the entrance easier into some markets, not at all. Medical, implants, automotive, and all these safety relevant things. For sure, they need to have statistical population, and it must have to have that. But a lot of markets, they have such a high barrier, and that kills a lot of energy, and that kills creativity in a massive way. So that is my opinion to say, hey, there's something to improve.
Okay. If I can ask a colleague to grab a microphone in case there's any question. Any questions from our audience today? There's one right at the back there, back corner. Thanks, Kim.
Thank you very much for this overview. So I'm from academia. My name is Professor Igor Migrinsky from Aston University. So, and you see, so our PhD students, every 3 years, come into some industry, to some companies, that possibly some of you companies. And there was a very good point saying that industry should work close to academia. But my question also might be more tricky, saying, okay, so what's your vision? You know, what should we educate our PhD students on or focus more? So should it be artificial intelligence? Should it be quantum technologies? Should it be combination of something that these students will come to you and get a great success with development of companies, development of their own business, something like that. So where should we go? Your vision. Thank you.
Mike, do you want to pick up on that one because you talked about academia?
Well, I have the microphone, so I may answer first. I think one important thing is that the collaboration does not have to be mainly focused on application and technologies. Should be more focused on team working, like offering internships for students, having things like, which is very popular here in Germany, dual study programs that the university kids go 2 days a week for an internship in industry, and then go another 2 days a week to the university and start already a relation, a community, and grow into the business, grow into the job.
Anyone else want to come in on that?
Yeah, thank you very much. How to explain? Take a look into the landscape. For example, Netherlands, Finland, Korea, and lots of other countries. They have like a pyramid. Somebody is top down going and says, we will spend 10 billion this year for education on university level. And then they are bringing 5 to 10 programs. It's called like healthcare, it's called like agriculture, so far, so on. So everybody sees a name, and then the question to the universities was made in the last years, how to go there. For that, they have developed associations, technical driven associations, and so far, so on. I guess that's a good way to go. A little bit like top down, because somebody has to spend the money. That is a top down affair. And then bottom up to bring up the ideas where to go. That's the first one. The second one for sure is completely what Georg said. I think we have to accept and we have to explain to especially the consecutive students, not everybody will get the Nobel Prize. And that generates a lot of frustration that people in the age of 16, 17, 18, as we have all been years ago, started with the mindset, hey, Nobel Prize would be nice. But there is just one prize per discipline per year. And maybe 1 million or 10 million or 100 million people who want to reach that one. What happens with the rest? They get frustrated somehow, somewhere. And this frustration, how to bring it away. So maybe we have to talk a bit more open, a bit more transparent. This world is a dirty one. We must be quick. And we have to do it as a community. Nobody can solve the problem alone. And when we get that team play into the universities back, being a team player, not an elbower, that helps massively, that they have more freedom to find the right study for themselves. And then talking about technology and not about a product. Nobody can fix a product without the acknowledgement. So first, back to technology, to easy skills, step by step, and then talking about products maybe in 5 years or 10 years, and also with some practice. More practice is also a helpful thing.
Thank you. Anton, any engagement with the academia on your side?
Yeah, sure. And I believe it was already quite well covered for the moment. But what I probably would mention, I think from what we see from our side when we hire especially new graduates or the people who were coming from the academic environment, it's not about the fundamental research versus applied research or about which topics we need to educate. I believe sometimes what we're missing is industrial mindset or industrialization mindset, because sometimes we have quite a lot of super good research with great results, but then there is just no person to pick it up and try to commercialize, to try to bring it to real applications. And this is something which we really need to work on. And what it also takes an understanding, because we see some brilliant minds coming from the academia. They're doing the cutting edge research, but then they have no idea about what is the current state of the industry. They do not have the grasp that on the industrial level, on the engineering level, you still try to optimize and to make repeatable processes which have been shown in academia probably 5 or 10 years ago. So there is always a bit of a mismatch between what they were doing and what they're expecting from the industry. So we need to close this gap. And typically it's also being closed by probably all the statistical methods or industrialization methods that you don't target as an academic just a hero device, because this is quite often the case. The industrial mindset would be how I make my process to be able to repeat it hundreds of times, thousands of times if it's needed, because it takes very different mindset and very different approach to the design of your system, to how you think about it, to how you implement your processes. And from our perspective, this is something that we are quite often missing in the graduates or people coming from the academia.
Okay. Thank you. I think that's a very good point to end. I think what I would say is this community as it is, which has a mixture of academics and startups and vendors and OEMs and integrators, is the perfect place to have those conversations. So when we break in a little while and we move for food and drinks, start having those conversations today, right? Okay, can we please thank our panel for this argument and discussion?